So as we look at number 8, it says, use the given data to find the equation of the regression line. So let's go to our exam notes and find the equation of the regression line. So where is that on our exam 4 notes? Come on back here. So, see, it's going to be number 8 again, huh? Whenever they mention regression line, it's either 8 or 9. 8 or 9 for sure. It's going to be number 8, linear regression t-test. That'll give us the equation, right? So basically put the data in L1 and L2 and do linear regression t-test. That's all we need to do. It'll be a quick, easy one. Let's go back. So this is L1, L2. Put the data in L1, L2, and then go find linear regression t-test. So L1, L2, linear regression t-test. We're always choosing not equals, right? That's what it says back there. If you look at the, right, not equals. Okay, so when I hit the buttons, I'm getting y equals a plus bx, where the a is 140.4 and the b is negative 6.2. There it is. D. We good? That's exactly the way the real exam will look. Yeah, plus negative 6.2 is, this is just minus 6.2. It's the same. It's the same as just adding a negative is the same as just subtracting. In other words, good question on that. Yeah, so it's plus the negative, which is the same as just subtract. So here we go. Benford's law. You know what to do with Benford. Oh, it looks a little weirder. Yeah, this one, yeah, it's good that we see the way it'll actually look. Yeah, this is kind of confusing for students on the exam. I'm not meaning to. It just comes out this way from the test generator that comes with the book. But anyway, remember what we're going to do. We're going to take, this is goodness of fit. Benford's law is goodness of fit. You can count on a Benford's law question for sure. You know, I think it's a good law. It's a valuable discovery. Anyway, so what goes in L1? What goes in L2? Remember that L1 is always the list that's observed. In other words, not calculated, right? Not just given to you on a silver platter. So what's that? That's these numbers right here. Yeah, it's flipped in order, isn't it? And that's what tricks people on that. Yeah, so they're not trying to trick, they're just presenting normal information. But you got to remember, L1 is the observed numbers. So it's 0, 12, right? So those numbers are going to go down L1. 0, 12, 0, 73, 482, 186, 8, 23, 0. Those are L1 numbers. How do we know? Because those were not calculated. They were just observed. That's what they saw, right? The frequencies were found to be observed. Found to be. And then what do we do for the L2 numbers? You know how that works, right? L2 is going to be each of these percentages. So L2 is going to be 0.301, you grab that first percentage, times, how many total checks here? 784. And then 0.176 times 784. And then 0.125 times 784. And on down the list you go. Does that make sense? I go dot, dot, dot. Just go right on down this list. Multiplying each one of those times 784 and put that in L2. I could write the rest. It's just going to get over those words. It's going to be 0.097 times 784, 0.079. There it is. So there's L2, there's L1. Put the data in L2 and L1. So this is goodness of fit. We're going back to, this is goodness of fit right here. HO is that they fit. H1 is do not fit. Put the observed values in L1. Calculate the expected values and put them in L2. And then if you have a TI-84, you got to do chi-square goodness of fit. Degrees of freedom is number of categories minus 1. If you have a TI-83, you just hit program chi goodness of fit. And you got it. So let's go back to that. So I'll do chi-squared goodness of fit test. Degrees of freedom, number of categories minus 1. How many categories are there? 9, right? 9 different digits. 9 minus 1, so 8 degrees of freedom. Chi-squared goodness of fit, go on down, 8, calculate. So I'm getting a p-value that is 0. Mine came out 0. Did you guys get that? So that's certainly, that p is low. I don't even need to look at what the significance level is. That's low as you can get. P is low. HO must go. Now, notice that we have to actually conclude the meaning here on this one. So we gotta know what HO is and what H1 is if we're to draw a meaningful conclusion on this one. You see the trick? So what is HO? Well, if you go back to goodness of fit test, HO is that they fit, and H1 is they do not fit. So HO is that they fit, and H1 do not fit. And we're saying the HO must go. So cross out HO, keep H1. And we know whenever you're doing H1, that's strong evidence, isn't it? So there's strong evidence that they do not fit. Strong evidence that the data doesn't fit. So Benford's law is saying something's up here, right? Somebody's monkeying with the numbers because the natural pattern of leading digits is not fitting with Benford's law says humans do. So it does not fit, strong evidence. So sufficient evidence, therefore we conclude that the checks are not the result of fraud? No. B, sufficient evidence, we conclude the checks are definitely the result of fraud. There's strong evidence that somebody's monkeying with the numbers. They don't fit the normal human behavior that Benford has noticed, Benford's law. Good on that one? Like you could do that, and it looks that way. You'll keep your L1, L2 straight, right? That's the part that tricks people. Because L, the percentages are on the top. People tend to take those percentages and put them in L1, and that gets everything wrong. You got to know it well enough. You got to use those exam notes carefully enough to observe. L1 has to be observed values. L2, calculated expected values, right? So the percentage calculations, those go in L2. L1 has to get the observed numbers. So don't reverse that. That good? I'm sure there'll be a Benford's law.
So the L1 is the null, the claim.
No.
The
observed values.
Observed values.
Yeah, it says it right on the exam 4 notes.
Okay, so in this question, it's stating that does it appear that the checks are the result of a fraud, which would make it, you're looking for the strong evidence part instead of weak evidence to prove that claim itself.
And that they don't fit. Strong evidence, yes, and that they don't fit. Right? Because Benford's law says normal human behavior, leading digits will look like this pattern. And so if we look at a bunch of checks and they don't fit,
then that would claim that it is a fraud. Okay.
It's a fraud. Yeah.
Okay, got it.
Strong evidence it doesn't fit.
Okay.
That makes sense? Good question. Everybody clear on that? Yeah, strong evidence it doesn't fit the normal human pattern that Benford's law has noticed. That's what Benford's law is, the normal human pattern on leading digits. And so if a bunch of checks don't fit that, somebody's writing false checks. Good. All right, number 10. Studying the responses to multiple choice test question. The following sample data were obtained at the 0.05 level. Test the claim that the responses occur with the same frequency. Find the p-value. This is indeed, this is good as a fit. What's the key word here? There it is. Same frequency. That's the same thing as equal frequency, isn't it? Same is equal. Yeah, if you look back to goodness of fit, it has that word. That's exactly it. Right here, equal frequency. That's a goodness of fit thing. So it's equal frequency, goodness of fit. So if we go back to the problem, we go, okay, goodness of fit. So now equal, what do you do for equal? They're saying make all those equal. So remember, it's just like the babies being born problem, right? Same number of babies every day. We're saying same number of frequency for all those. It's a bunch of people who took multiple choice tests. And they're saying, hey, did they have the same number of A answers as B, as C, as D, as E? Are they all the same? Well, clearly not. But are they close? That's kind of what we're answering. And so we want to figure it out. Well, so we got to see how well it fits with if they were all the same, equal frequency. So you got to find out if they were all the same, if there were the same number of answers for A and B and C and D and E, how many would there be for each category? So did you figure that out? We got to add all these up, don't we? Somebody got the total there? 80? 80. And then we got to divide by 5, huh? Because there's 5 answers. So 16 per category? So then 16, 16, 16, 16, 16. So if the answers, the multiple choice answers were occurring with equal frequency, there would be 16 A's, B's, C's, D's, and E's, huh? Just like same number of babies being born every day of the week problem, right? Equal frequency. So which one's L1 and which one's L2? Remember, L1 is always the observed, and L2 is the one you calculate. So we just calculated the 16, didn't we? So that's our L2.
Wait, how do you know it's divided, not multiplied?
Because we're figuring out how many for each category. So there's 80 total answers were given. 80 total answers. And there's 5 different types.
Oh, okay.
So divide by 5, there's 16 of each type. So it'd be L2 and L1 is the top row, huh? Because L1 is always the observed, what they actually saw happen, and L2 is what you expect. If they're equal frequency, we would expect them all to be 16. So put that in L1 and L2, and then do chi-square goodness of fit test. It's a fit test. If you have a TI-84, you got to put degrees of freedom, which is number of categories minus 1. So how many categories here? 5. So 5 minus 1 is degrees of freedom is 4. There's 5 different answers, right? A, B, C, D, E. 5 categories. Minus 1 is degrees of freedom 4. Calculate. I'm getting a p-value that is 0.759. Right? Did you guys get that? And so what's the answer? Oh, it's disturbing, isn't it? It's not there. Is that good? So number 11, table below shows the age and favorite type of music of 668 randomly selected people. Use a 0.05 level of significance to test the claim that age and preferred music type are independent. Yeah, so we see the word independence. We go back to our exam 4 notes, and we see test for independence. HO is independent, H1 is dependent. And we're going to do that test. That's where you got to go to second matrix and put stuff in the matrix menu. So we go second matrix. This is a test for independence. Does what kind of music you like, is that independent from how old you are? I don't think so. Got to hit second matrix, edit, and put in the data. It's a 3x3 matrix. So you go second matrix, put in the data. You got to choose 3x3 for the size. 3x3, and then put in the data. put in the data, and then you got to do chi-square test, and my p-value is coming out to be 0.0115. Yep, there it is. 0115. Okay, so number 12. 160 students who were majoring in either math or English were asked a test question, and the researcher recorded whether they answered the question correctly. The sample results are given below. At the .05 significance level, test the claim that getting the question correct, incorrect, and major are independent. There's the key word, right? Independent. So this is a test for independence. So we look back at our exam 4 notes here, and there it is, test for independence. So HO is independent, H1 is dependent. And we got to do the second matrix. To get to the matrix menu, go to Edit, hit Enter, and select the size of the matrix. And then input the matrix, and second quit, and stat test, chi-square test. So let's go to it. So, okay. So, test for independence. So here we go. So I'm going to put this in the calculator. So second matrix, and then when you hit second and matrix on your calculator, you got to go over to the edit menu and hit enter, and then the size, choose the size. This is a 2 by 2. You got to hit 2 enter, 2 enter, choose a 2 by 2 matrix, and then put in the data, put in these 4 numbers into the calculator. And then when you're done with that, and you come on down, and you're going to hit stat and tests, and you're going to go all the way to chi-square test. So not goodness of fit, but just chi-square test. So do the chi-square test, and I'm getting a p-value that is 0.01. Okay, so now that what's our significance level? There it is, 0.05. So 0.05 is the significance level. That p-value is low. Clearly, it's less than the significance level. So p is low. So we know that means the HO must go away. Now the question is, what is the HO? Because this time it's requiring us to actually answer real-life words here. So what is the HO on a independence, test for independence? Let's go back to the exam 4 notes again. Exam 4 notes, test for independence. HO is that they're independent. H1 is they're dependent. So again, it might help you to add to the word independent. That means they do not affect each other, right? If two things are independent, they don't affect each other. Whereas dependent means they do affect each other. So independent, they do not affect each other. Dependent, they do, right? If two things are dependent on each other, they depend on each other, they affect each other. So, all right, so HO is independent, H1 is dependent. Let's go back to it. So here it is. So HO is independent. H1 is dependent. And remember, weak evidence always for HO, strong evidence always for H1. Okay, now HO, right, the P was low, right over here, the P was less, P was low, so HO must go away. So cross out HO, keep H1. So that we believe that they're dependent and evidence is strong. So there is sufficient evidence, there is sufficient evidence. Yeah, it's going to be one of those, isn't it? Evidence is strong, sufficient. Therefore, we conclude that major is definitely related, or therefore we conclude that major is not related. Is major related to getting the question correct? Well, we concluded dependent. What does dependent mean? Remember back on the exam 4 notes. Exam 4 notes here. Dependent means they affect each other, right? Dependent, affect each other. So let's go back. So they affect each other. They're dependent. They affect each other. So we're going to say major is definitely related to getting the question correct. A, yeah, it affects it. Your major affects whether you get the question right or not. Whether you're an English major or math major has an effect upon you getting your score on the test, getting the question correct or not. So there we go. All right, number 13. So this was probably easy for you. Looking at that scatter plots, they're saying which one is R is negative 0.996. Remember how it works? This one would be R is negative 1.0 because it's going down in a perfect line. This one is R is positive 1.0 because it's up in a perfect line. This one would be R is positive like 0.9 or something because they're up but not in a perfect line. This is the one that would be the negative 0.996. That's the one they're looking for because that's going down but not in a perfect line. So when R is negative, the lines are going down. When R is positive, the lines are going up. And if they're in a perfect line, it's 1.0, or a perfect line down, negative 1.0. If it's close to perfect, it's like 0.9, positive or negative. This other one, R would be close to 0. Like R would be like 0.2 or negative 0.2 or positive 0.1 or negative 0.1 or something like that. Close to 0 because there's no line on that one. All right, and then the last one, number 14. The paired data below consist of the cost of advertising in thousands of dollars and the number of products sold in thousands. So find the value of the linear correlation coefficient R. So where do we get the linear correlation coefficient R from? Let's go back to the exam 4 notes. So all the linear correlation stuff is right here on number 8 and number 9. So we're going to do linear regression t-test. Put the data in L1 and L2, do linear regression t-test, and choose H1 R not equal to 0. Linear regression t-test. Okay, let's go back. So that's what we're going to do. So L1, L2 for the data. Let's put that in our calculator. So after you get that in your calculator, then you go to linear regression t-test. Under stat test, linear regression t-test, and you choose the not equals. On that, we always choose the not equals as it says on the exam 4 notes. Let me go back and show you that again. See right here, not equals on the exam 4 notes. All right, and so hit calculate, and I'm getting, now R is way down at the bottom. So you got to go down, down, down. I'm getting, there's an R squared, and then there's R, 0.708, 7077, around 708. There it is. There's our R value. So there's the whole test. The real exam will be very similar to this exam.